my homework is very long. Well, okay. I'm almost done. Now I have understood that periodic behavior is like, for example, a periodic function repeats itself for a very long period. For example, a snake that goes in the same speed and same amplitude when it moves, you could say it is a periodic behavior, which also applies to simple harmonic motion. And how can I evaluate these functions? Well, with the equations, I can use either sine or cosine, which I very like. For cosine, I will express my function as y equals a, that is the peak of the amplitude, times cosine of 2 pi fx plus theta plus h, where f is the frequency and theta is the distance of the movement that is taken in time, and h is the vertical shift. If I want to use a sine, I can express my equation with the following: y equals a times sine of 2 pi f of x plus theta plus h, and the variables are the same. Now, what is the amplitude? Well, it can be described using the following notation. And how I can observe is that amplitude is an absolute value. This represents the ordinate of the equilibrium, and this represents the ordinate to the highest or lowest value. For period time, I can represent the following equation. Period is how much time you need to end one cycle, and it's normally measured in seconds or milliseconds. And frequency is how many cycles are done in 1 second. So the units are revolutions per minute and hertz. And for last, what is damped harmonic motion? Well, I've understood that damped harmonic motion is pretty much the same as simple harmonic motion, but with the difference that the amplitude decreases as the function goes on. And that happens because of friction. Friction reduces the energy of any oscillation, and eventually it will stop. Blood pressure. Each time your heart beats, your blood pressure increases, then decreases as the heart rests between beats. A certain person's blood pressure is modeled by the function PT equals 150 plus 25. Find the amplitude, period, and frequency. I don't know how to do this.
Well, the problem involves here heartbeat. So logically, like the heartbeat, dun, 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 that's harmonic motion application, right? So in order, if they give you the formula, this is 115 plus 25 sin of 160 pi times t. Well, first you need to identify like the concepts or some values. T stands for time, and pt, well, is the y-axis. So this value will depend on the function. 150 represents your equilibrium axis. That means that it is symmetrical. The distance from here to here by 2 gives you the equilibrium axis because it's symmetrical. And then you have 25. As you can remember, this 25 represents the amplitude, which is 25, because from here to here is 25. That means 140. That's your highest point, and then your lowest point is 115 minus 25. That gives you 90. Okay, and then this is your argument. So you have 2 pi, which is the normal period, over 160 pi. You cancel pi, and that gives you 1 over 80, right? And 1 over 80 right here is the time that will take you to the function repeats itself. That is in seconds, in units. So logically, because it is a very short period, the frequency must be like higher, and the frequency is 1 over t. That's for the use of seconds. So 80 hertz, because it does the same movement 80 times in just 1 second. Then we plot the most important points, which is the highest point at the crest, and is 1 over 320, 140. 140 represents the highest point because, as you can remember, 115 is the equilibrium axis plus 25, that is the amplitude. And then 115 minus the amplitude will give us in 90. And the other point, the lowest point, will be 1 over 116 over 90.
The electric generator. The armature in an electric generator is rotating at the rate of 100 revolutions per second. If the maximum voltage produced is 310 volts, find an equation that describes this variation in voltage. What is the RMS voltage? I still don't know how to do this.
The problem says that the armature is rotating at 100 revolutions per second and that the maximum voltage is 310. So from that we can get that 100 is the frequency, the period is going to be 200 pi, and the amplitude is going to be 310. From this we can get to the formula. P of t equals 310 cosine of 200 and pi t. This is because it's a harmonic motion. And the RMS, that means root mean square, it's telling us that the maximum voltage time is the maximum voltage times 1 over pi over 2. In this case, the maximum voltage is 310 times 1 over pi over 2 is going to give us approximately 219.20 voltage.
So you may be thinking, what the hell I just did? Well, we answered the questions, but in fact, a harmonic motion have many different things that we can use. Like for example, we have here the sunrise, that actually you can know from a period of time when it's gonna repeat itself. Or in the tide, and sometimes we have a high tide and then a low tide. And then this process repeats again and again, so that's another use of harmonic motions. And for example, a pendulum that goes from one way to another, back and forth. And a spring, when we exert the force on it, then it's gonna expand and then it's gonna compress again, so it's in a cycle.